First one says the current flowing through a 10 kilo ohm resistor. I know that's the resistance because it says resistor, but also because it has that ohms in it. Now, this question in an exam would say show clearly you're working out. And the reason it would say that is you can get the right answer by doing the wrong thing. And if you did it that way, you wouldn't get any of the marks. So the first thing I need to do is, it's kilo ohms, same thing I would do if I had kilometers. I multiply by 1000 and I get that as 10,000 ohms. Current is 50 milliamps. Same thing with millimeters. I divide by 1000 and get 0.05 amps, and I'm trying to find the potential difference, which is just voltage. Okay. I then do V equals IR. V equals 0.05 times the 10,000, and it gives me 500 volts. Now notice, if I multiplied the 10 by the 50 at the start, what answer would I have got? 500. Would I have got any marks? No. If this was a question in exam, you wouldn't get any marks for your answer if you just wrote it down. It would say show clear that you're working out, and anytime it does that, make sure you put in all your steps in. Okay, so do lay out your work neatly and show all the different steps that you do. Okay, next one. We have a voltmeter across our resistor, always connected in parallel, that tells us the voltage across it is 2 volts. The ammeter is before our resistor, but it's in series with it. So if the current through the ammeter is 5 amps, the current through our resistor there is also going to be 5 amps. And we're asked to find the resistance. V equals IR, 2 equals 5R, 2 divided by 5 equals R. So R is 0.4 ohms. Make sure you have your units in there after your answers as well. Question 3 is more like the kind of thing you're going to get in an exam. Okay, so we say that Ohm's law can be applied to whole circuits, it can be applied to parts of circuits, it can be applied to single components. So first thing we're going to look at is really this first resistor here. And it tells us that the resistance is 2 kilo ohms, which is 2000 ohms. It tells us that the voltage is 3.5 volts, and it asks us to find out the current. V equals IR, 3.5 equals 2000 times I, gives us I, divide by 2000, gives us 3.5 divided by 2000, is 1.75 by 10 to the minus 3. You're okay, if that's what your calculator says, you're okay leaving that in standard form. And make sure you have your amps after it as well. Okay. Now, another way I could say that is 1.75 milliamps, or I could say 0.00175 amps. Any of those work. Okay. Now, what I know is that the current flowing through this first resistor is 1.75 milliamps. But where does it go after it goes through that resistor? Through the second one. So by working out the current through the first resistor, I now know what the current is through the second resistor. Because they're in series, and from our previous booklet what we learned was if components are in series, the current is the same through all of them. It has nowhere else to go. Okay, so we can then look at this second resistor and do V equals IR for it. Okay, so V equals I, which is 1.75 by 10 to the minus 3, same as in the first one. The resistance of it is 3000. Put that into our calculator and we get that the voltage is 5.25 volts. Okay. Last question then. Says the following graph shows the voltage current plot for a particular resistor. Sketch a line on the graph to represent the plot for a higher resistance. This should say I down here. What we know is that when voltage is on the y-axis and current is on the x-axis, because of V equals IR, R is V over I, therefore R is equal to the gradient or steepness of the line. Therefore, if we want a higher resistance, it means a higher gradient. So we should draw a line that is steeper. So that would have a higher resistance.